All right, welcome. Today, we're going to dive into the world of rational numbers, but with a fun, delicious twist. We're throwing the ultimate pizza party. And believe it or not, the same math that powers our world is exactly what you need to keep a party from turning into total chaos. Let's get started. So, picture this. The party is perfect, the music's great, and then the pizza arrives. All of a sudden, you're not just a host anymore. You're a mathematician in disguise, and you're facing some surprisingly tricky questions.
Look, we've all been there, right? You're trying to make sure everyone gets a fair share, you're figuring out how to combine leftovers, and then comes the final boss, splitting the bill without starting a civil war. Let's solve these, one slice at a time.
Okay, so first up, let's tackle the easy stuff. Everyone's eating from the same pizza, which introduces us to our first and friendliest type of fraction.
So this pizza's cut into 8 equal slices. You grab 3, your friend grabs 2. You don't even need a calculator for this, right? You just count them up. 3 plus 2 is 5. So 5 out of the 8 slices are gone. It's just that intuitive. So what we just did there, that's called working with similar fractions. And what's really interesting is why it's so easy. It's all because the denominator, that bottom number, is the same. That number just tells you how many equal slices the whole pizza is cut into. When the denominator is the same, all the slices are the same size. We're comparing apples to apples, or, pizza slice to identical pizza slice.
And here it is, the golden rule. When those bottom numbers match, you only need to focus on the top numbers, the numerators. The numerator is just telling you how many slices you're actually dealing with. So just add or subtract them and leave that bottom number alone. It's just there to tell you the slice size you're working with. All right, you've mastered the single pizza. But now, things get a little trickier. The party's a hit, and now you have leftovers from different pizzas. Let's see how this builds. So now you've got this puzzle, right? A slice from the pepperoni pizza, which was cut in half, is way bigger than a slice from the cheese pizza, which was cut into thirds. You can't just add 1 and 1. It wouldn't make any sense. So, what do? And bam! We've just run into what are called dissimilar fractions. With different denominators, they represent different sized pieces of the whole. Trying to add them directly is basically a mathematical impossibility. It's like saying 1 big slice plus 1 small slice equals 2 medium slices. It just doesn't work. But don't worry, mathematicians came up with a powerful tool for this exact situation. A secret weapon to bring order to all this fraction chaos. It's called the least common denominator, or the LCD. The LCD is our magic number. It lets us kind of re-slice both pizzas in our mind so that all the new slices become the same size. And here's the real aha moment. This isn't just some math trick. It's about finding a common ground. We're making the fractions speak the same language by changing how they look without changing their actual value. Okay, so here's how the magic works. First, we find our magic number, the LCD of 2 and 3, which is 6. Then we convert our fractions. That 1/2 of the pizza is the same as 3/6. The 1/3 is the same as 2/6. And just like that, we're back to adding similar fractions. 3 plus 2 gives us 5, so we have 5/6 of a pizza in total. The party's winding down, but there's still pizza left. Now we face a new kind of question. It's not about adding, but about taking a piece of a piece. So you don't want the whole 3/4 that's left over, you just want half of it. Now that little word of is like a secret code in math. Whenever you see it, it almost always means you need to multiply. You're finding a fraction of a fraction. And this slide shows you exactly what's happening. See the first shading? That's the 3/4 of the pizza that's left. Then we take half of that area. The part where they overlap, that's our answer. That's the fraction of the original whole pizza that you're eating. It's a really brilliant way to see what multiplication is actually doing. And honestly, here's the best part. The rule for multiplying is incredibly simple. You can forget all about common denominators. You just multiply straight across. Tops with tops, bottoms with bottoms. That's it. It's the most straightforward operation of them all. All right, the plates are empty, the guests are happy. All that's left is the final challenge of the night. And this one requires a different kind of number. Yep, it's time to talk money. The bill arrives, and of course, it's not a simple fraction. It's got that little decimal point. Money is the most common way we all use decimals every single day, often without even thinking about it. Really, decimals are just fractions in disguise. The number to the left of the point, that's your whole part. The numbers to the right are the fractional part. So pay 13,250.50 is just another way of saying 1,250 and 50/100ths of a peso. They're just perfect for precision, especially with money. So, when you divide that total by 5 friends, decimals give you a perfect, clean answer. Each person owes exactly 250 pesos and 10 centavos. No messy fractions, no arguments. Everyone knows precisely what to pay. Problem solved. And there you have it. You survived the pizza party. But in the process, you've equipped yourself with a genuine superpower. And this goes way, way beyond pizza. You're using these exact same skills when you're baking, doing DIY projects, navigating with GPS, or even managing your finances. Fractions and decimals are like the invisible language of our everyday lives. Think about it. You started with a really simple problem, sharing a few slices, and you leveled up with each challenge, combining leftovers, finding a part of a part, and finally splitting the bill. You've seen how these numbers work together to help us make sense of the world. You've basically unlocked a new way of thinking. So the only question left is, with this power to understand, measure, and divide the world around you, what problem are you going to solve next?